Hi, in this video, we'll be continuing doing the H2 Mathematics 2021 Paper 1. And so let's start. We left off with question 4, and for question 5, they want to express x over x plus 2 times x plus 3 plus times x plus 4 in partial fractions. And so the idea is to break it into partial fractions, it is always some constant over the denominator term factors, be it is a linear factor or it's a simplified quadratic factor. But in this case, it's just 3 linear factors, so you just break it into this form, and then you want to find the constants a, b, and c. To do so, imagine you now want to combine this term into one term. Then you need to multiply by x times plus 3 times x plus 4, because you times above times below. Same for all this. Then you add together, and by comparison, this must mean that x is, it must all equals to x. So you just now you want to solve for a, b, and c. So to do it, you just sub x equals to minus 3 first, then this term and this term cancel, then you just find b. Similarly, you sub x equals to minus 4, you get c, and x equals to minus 2, you get to cancel these two terms because this part is 0, and you get a equals to minus 1. And so the partial fractions form will be as follows. Next, they want us to use what we know to solve for this sum. Well, because it's a hence, and we recognize this problem as a sum of difference, what we need to really do is break this term into its partial fraction form, and we see that we write it out, we see after 3 lines. So a general rule of thumb, if there's 3 terms here, you just need 3 lines, and you can see the pattern. So it cancels out diagonally, and you just write the last 3 lines again, and we just see this part to be we just choose these 3 terms again as the remaining 3 with this top 3, so you get this answer in the end. I hope that's clear. So the trick is, if you see 3 terms in your sum, then you just need to leave like this triangle of 3 terms. But the general rule is you just write 3 lines, and then you see the pattern, and then you start cancelling. And when you simplify it, we want to state the value as this goes into the long run, meaning as n goes to infinity, well, this part will go to 0 and this part goes to 0, so the answer will be 1 over 6. So I hope that's clear. Now for question 6, it's sketching of graph. So we give you this equation, and we're supposed to sketch C. So you can just quickly use your GCE and sub in a value of a that is like larger than 0, and you can roughly see the general outline of C. Now, the thing is, you want to find the minimum point. It has to be where this part is the maximum below, the denominator is maximum, so you just want to maximize this, which is at x equals to 2a, so y equals to 1 over 2a. Then you want to find the asymptotes as well. Well, that's when the denominator is 0, so that is when x equals to 4a and x equals to 0. So you just need to plot out the asymptotes and draw the rough shape. Now we want to find the smallest possible value of y, which we already found to be 1 over 2a. And we want to describe transformations that map the graph C into this new graph. So it might look quite different if you think about it. Like, this is 4a squared minus x squared, but here is 4ax minus x squared. So the idea is you need to write this in some form where it's a constant minus something. And to do so, you need to recognize that this part you need to first complete the square. And once you complete, you actually get very nicely a 4a squared, and you get this term here. So to convert from y to c, we need to change x minus 2a to x, meaning we need to sub x as x plus 2a. That means we translate 2a units in the negative x direction. So if this part is confusing, just leave it in the comments and I will answer it again. So for question 7 now, we are given y equals to e to the power of sine inverse x, where x is some restricted value. And we want to show this equation holds true. So this is really testing you on your techniques of differentiation. And so we just firstly write y is this. So common tricks is you can just immediately differentiate it, but what I like to do is get rid of the e, because in the end we know this is an implicit formula because there's y and x together. So you can just ln y to get rid of the e, then you differentiate, it will be 1 over y times dy dx equals to this. This also means that square root 1 minus x squared equals to times dy dx equals to y. There. So then from here we just use power rule because now all these are in the x's. So you just power rule it. So when you differentiate dy dx, you actually get d squared y dx squared again. And for this side, you just need to get dy dx. You shift the terms around, you should get this. And then you must recognize this is actually y. So this is just become y, you bring this over and you get the equation that they want. And now with that, you want to find the first 4 term of the Maclaurin's expansion. So Maclaurin expansion means you just need to find f0, f prime 0, f double prime 0, which you can do because you have these equations already. And f0 is just sub 0 here. But the next thing is they want first 4 terms, so you still need the f triple prime 0. So you again you differentiate this once more and then just quickly do a substitution, and you could get that third derivative of f equals to 2 when you sub in 0. And so you just use the formula, so it's f0 plus f prime 0 x plus f double prime 0 over 2 factorial x squared plus f triple prime 0 over 3 factorial x cubed plus so on. And you should get 1 plus x squared over 2 plus x cubed over 3. So I hope what I've explained is clear to everyone. That's all for this video, and I'll catch you in the next one. Please like, share and subscribe, as it really helps boost this channel to reach out to further audience. I'll catch you again. See you. Bye.